Hello everyone, welcome back to another video. Today's video we're going to focus on reducing the power consumption of my Unraid box that's solar powered. Let me flip the camera over and show you what we're working with. Okay, so for anybody that hasn't seen it yet, the top server here is my Unraid box. And the power consumption idle is right around 200 watts. Dips down to about 180 when it spins down the hard drives, but you can see it fluctuating there. So I'm going to show you what I plan on doing to lower the power consumption. Alright, on my workbench you'll see I have some new processors. These are actually low powered Xeon processors. They're the E5 2430L. They actually use 60 watts is their thermal package. The current processors I have in the server are E5 2420s, and they are 95 watts thermal package. So by swapping out the CPUs, we can reduce the power consumption of the server. I'm also going to take the opportunity to put better thermal compound on the chips, because less heat generated should use less power to spin up the fans and everything of that sort. And also the NVMe drive I have in there, I have a spare heatsink for it, so I'm going to put that in there, hopefully cool that down a little bit. These processors are actually pretty good, and I'll put something on the screen. These are basically the same thing I have in the server now. I got the processors in my server when I acquired it, and they've been working fine, but these are about the same performance, but with less wattage. So I'm going to put the server on my workbench, and let's get started. All right, I have the server on the workbench here. Took the lid off. All we have to do is remove this shroud right here, and we'll see the processors and the heat sinks. There we go. So you got two processors and you got the heat sinks. The one thing I've always wondered about this server is this heat sink is the fins are not in line with the airflow, so the airflow from the fans would come in and go this way. I don't know why they did it this way, and you can see that it's designated to sit that way, so that's from the factory. Doesn't really make much sense to me, so I may switch that around. I don't see anything that would hurt if that switches around, but for right now I'm just going to pull the heat sinks off and get to swapping out the processors. Alright, I removed the heatsink off the first, or this is actually CPU 2, you can see it there, but I just wanted to show, even if I wasn't switching out the processors, the thermal compound on these CPUs have dried up, become dry and everything. Even just removing that thermal compound and putting new on, fresh new, that would actually help with heat. So that's one little tip that you could do to reduce power consumption a little bit. That wouldn't reduce it by much, but every little bit helps. So I'm going to go ahead and remove the other heat sink, and I'll show you what it looks like. Okay, so I've cleaned up the heat sinks here. I got all the old thermal compound off of it, wiped it off pretty clean. I also put in the new CPUs. You can see, maybe this one will be a little bit easier to see. Yep, E5 2430L. The L stands for low power. And then the old CPUs are E5 2420s. These were actually 1.9 gigahertz, and I believe they turbo boosted up to 2.4. The low powered Ones are 2 gigahertz, and I believe they boost up to 2.5. So I gain a tad of performance, nothing that I'll notice. But the power savings I should notice. So I'm going to go ahead and put on the thermal compound and put in the heat sinks, and then while I'm at it, I'll put the thermal pad on the NVMe drive, and I'll actually show you guys that, and then we'll button it up, put it back in the rack, and see what it does. Alright, we have the CPUs installed, new thermal compound, both heat sinks are installed with proper airflow. Like I said, I don't know why that one was installed the way it was from factory, but there's no clearance issues or anything of that sort. Mounts up perfectly, so I think that's going to work better that way. Alright, so now we have to focus on the NVMe drive. I'm going to put the thermal pad on that, so all I have to do is take out this riser card real quick, and then I'll show you the thermal pad. Alright, riser card is out. Here's the NVMe drive. This thermal pad, it actually has a plastic coating on both sides that you need to peel off first. And once you peel off that, you put the thermal pad down, and then you can put in the heat sink, and it will the adhesive on that thermal pad will hold it in place. I'm going to do that and turn the camera back on. Alright, heat sink is installed on the NVMe drive, so we should get a little bit better thermals out of that. This heatsink actually came with the second adapter that I bought that I actually like a lot better than this one. This one sits the card a little funky. You can see how it's like not sitting right, in my opinion. Anyway, got the NVMe heatsink on. I'm going to slap it back together. We'll put it in the rack and see what our power draw is. Alright, got it back in the rack, booted up. Also, we switched to solar. Woohoo, awesome. And if we look at our little watt meter here, you can see it's steadily at 172, 73 instead of 200 or 180. It rarely hit 180. It would hit 180 and then bounce back up to 200. So I would say a consistent 200 versus 170, 172, 74. I think that's a pretty good improvement. Awesome. And also when there's less hard drive spinning, so once it realizes that it doesn't need to have all drives spun up, it'll spin down. Most of the time it'll spin down everything but 3 drives. So that means each drive is around 3 or 4 watts. We'll have some additional savings there. But I'm very happy with that. Just wanted to give a quick update. It's about an hour later, and with the hard drive spinning down, we're seeing much lower wattage. It peaks up to 140 every once in a while, but for the most of the time it's actually down into 120s. That should help out with usage a lot, so just another update. Thank you for watching this video. If you like it, please subscribe, hit the thumbs up. I do appreciate it. I will be making more videos like this to reduce my power on the solar side of things. See you in the next one. Bye.